Hello, in this video I want to talk about a type of synthesis reaction. It's a special type of synthesis reaction, and it's possible that you saw my other installments on synthesis reactions. In this particular video, we are going to take a non-metal oxide, which is carbon dioxide. Carbon is a non-metal, and combine it with water. And when you take a non-metal oxide and combine it with water, we produce an acid. In this reaction, carbonic acid is produced. And carbonic acid has the hydrogen ion in it and carbonate ion. And the acids can be recognized in their formulas. I'll write the formula for carbonic acid. H2CO3 is the formula for carbonic acid because it's forming from a hydrogen ion and a carbonate ion, which has a -2 charge, so H2CO3. So acids can be recognized by, when you look at their formulas, they often start with a hydrogen. So when students were in class, I challenged them to find a source of carbon dioxide, and their instructions were that they needed to bubble the source of carbon dioxide through the solution from a previous reaction. In the previous reaction, we took a metal hydroxide and combined it with water. It's another special case of synthesis reaction. We took a metal hydroxide and combined it with water, and it produced, I made a mistake when I said that. I'll rewind. We took a metal oxide, magnesium oxide, combined it with water to produce a metal hydroxide. And the evidence that this is a hydroxide that had formed in here is because phenolphthalein indicator turns pink in the presence of a base. So this is how that's spelled, phenolphthalein indicator, and on here you can see that it turns pink in the presence of a base. But if a substance is neutral or acid, it will be clear. So students had all kinds of clever ways to add carbon dioxide to the water, none of which were very practical, and I let them know that they walked in with perfectly good source of carbon dioxide, and when they saw the bag of straws sitting on the table, they quickly realized what I was getting at. So I'm going to use the carbon dioxide from my exhalations, my breath, which is a byproduct of body metabolism when we are digesting food, and I'm going to bubble the carbon dioxide into this solution, which we know is a base. There's also water in there because I put water in the last reaction. So as foolish as this may look, I am going to add the carbon dioxide to the water in this container, which we know there are also hydroxide ions in because it is pink. And I'll try to do this without passing out. It looks like it's getting a little bit lighter. I'll take it. And it's still showing a hint of pink. But now it has become clear. So what's happened in this reaction is we started with a base, and as I added carbon dioxide to it, the pH started coming down, and eventually it got to a point where it hit 7 because it was becoming more acidic as the new acid was being formed, and it turned clear. Now if the acid continues to be formed by additional carbon dioxide, the pH will continue to go down. Now this has some pretty serious implications because right now we are a society that is very dependent on burning fossil fuels, and one of the major products of burning fossil fuels is excessive amounts of carbon dioxide that we are putting into our atmosphere. at a very rapid rate compared to humans as pre-industrialized humans. Comparatively, our carbon dioxide emissions are much greater than they ever have been before. So what happens is the ocean water absorbs much of the carbon dioxide, and when the carbon dioxide reacts with water, we result in our oceans becoming acidified. So this is called ocean acidification, and this is one of the impacts on a global scale that excess carbon dioxide in our atmosphere is having on our oceans. Carbon dioxide in the atmosphere also contributes to an overall average warming of the planet through the greenhouse effect, which is a separate problem, but the two go hand in hand. If we are increasing our carbon dioxide emissions into our atmosphere, the ocean water actually absorbs about 20 to 30% of that carbon dioxide, but as a result of the abundant output that's going into our atmosphere, the ocean is absorbing more, and we are getting higher incidences of acid in our oceans, and the pH over time is going down, which is having very detrimental impacts on coral reef organisms and any organism that rely on making calcium carbonate as part of their shells. One of the problems with those organisms that are made of shells and calcium carbonate is that the acid breaks the shell down and sometimes even prevents the shell from forming with newly hatched individuals. So so there's still a little bit of magnesium hydroxide in here from the last reaction, and as it reacts you can kind of see a pink forming, but if I stir it up a little bit, the acidic conditions take it over and it still remains clear right now. So this was a synthesis reaction, a special case in which we take a non-metal oxide. Burning fossil fuels, especially in our internal combustion engines, produces other non-metal oxides like nitrogen oxides and sulfur oxides as well, which are also contributing to greenhouse gases accumulating and the water in our atmosphere and in our oceans reacting with these non-metal oxides to produce acid rain and ocean acidification. So synthesis reaction, again, we have a single product. We're making one thing, and I know that this video was a little bit longer, but this is probably one of the most impactful chemical reactions that are occurring on a global scale right now that could have long-term effects, and much research is being done to figure out how to minimize our carbon dioxide emissions and also deal with the fact that our oceans are becoming more acidified. So thanks for watching. I'll see you next time.